So we've just finished learning about interpreters and formal semantics, and we touched briefly on the halting problem. Surprisingly, although the halting problem is officially impossible to solve, it's actually one of my favorite areas in computer science. The halting problem and its cousin, Rice's theorem, are sometimes informally known as the law of interpreter-writer employability. Because it's officially impossible to solve all of these problems and get them right every time, there's always a market for people who can make close approximations or be almost right, be right most of the time, be right with high probability. We know it's impossible to do absolutely correctly, but nothing stops us from being 99.999% correct. So we keep trying with closer and closer approximations. In fact, a few years ago with a student, I was trying to do just that. We wanted to look at a program's source code and guess which lines were likely to be executed frequently without actually running the program. If we could solve this formally, we could definitely solve the halting problem, so we know it's impossible. But we can solve it for a subset of programs or be often right. You might imagine looking at the recursive definition for Fibonacci. If you're calling Fibonacci of 10, the recursive call happens much more frequently than the base case that just returns 1. Is there some way we can look at how humans write programs and figure out what's common based on that? It turns out we were able to extract this sort of structural information or comments that are present in human-written programs and figure out for them which lines are more or less likely to be executed or executed more or less frequently at runtime. So even though the problem is impossible to solve in practice, we actually view this as an opportunity. Because it's not possible to get it exactly right, we want to come as close as we can and reach for the stars.